unknown in the 1920s. So again, strong and weak forces were not even known in the 1920s when Einstein had just come up with or just contributed general theory of relativity and all that. Okay, so the strong and the weak forces unknown in the 1920s had been discovered and were largely understood. Some physicists suggested that Kaluza's original proposal had failed because he was unaware of these other forces and had therefore been too conservative in his revamping of space. So it could be that is it could be that because remember, actually yeah, remember that the strong and weak nuclear force actually do affect how we perceive the electromagnetic force, especially at different length scales. Because remember how we were talking about okay, well, remember how we were talking about Acacio says, I want to say in quantum physics. Remember how we were talking about sort of this cloud around, you know, the nucleus. The components of a nucleus interact with each other with a strong nuclear force, right, at the tinier length scales. So it's almost like when you consider the electromagnetic force between, say, the electron and the nucleus, it's like the electron and sort of this fuzzy thing, ball of stuff that also interact with each other. So the strong nuclear force actually does affect how you measure things, and it may contribute, like you might have to account for certain corrections because of the strong and weak nuclear forces if you're gonna be trying to be accurate or precise about the electromagnetic forces. So it could be that Kaluza did not know, right? I mean, he wouldn't have known in 1919 about the strong and weak nuclear forces because those were not discovered yet. So it is a shame. It is a shame. Things are not always known, so that could be part of the problem. It's still your work still has merit, Kaluza and Klein. So anyways, let's see what he's saying about that. Some physicists suggested that Kaluza's original proposal had failed because he was unaware of these other forces and had therefore been too conservative in his revamping of space. More forces meant the need for even more dimensions. More forces meant the need for even more dimensions. It was argued that a single new circular dimension, although able to show hints of a connection between general relativity and electromagnetism, was just not enough. One second, let me think about that. Hello, lol machine. What's the topic for tonight? It's string theory and its extra dimensions and sort of the foundation of that. That's the topic for tonight. Okay, so it was argued that a single new circular dimension, although able to show hints of a connection between general relativity and electromagnetism, was just not enough. By the mid 1970s, an intense research effort was underway, focusing on higher dimensional theories with numerous curled up spatial directions. There is a little picture here of that, which illustrates an example with two extra